here we want to find the derivative. Again, this d dx is just the shorthand for find the derivative of this problem. Well, the first part, x to the 5th, we know is going to turn into 5 x to the 4th. All right, so this answer's already out. And we know if this was e to the x, when we take the derivative, we just get back e to the x. But the rule for when it's not e is you get back the same thing, and you just have a correction term, which is the natural log of that number. So that kind of corrects the fact that we didn't have e, we had 5 instead. And that perfectly matches up with d. So this is just a formula that you have to memorize. What is the derivative of 5 raised to the x, or any number raised to the x? Okay, what is the limit as x approaches infinity of this problem? Well, the first thing you always want to do with limits is try to plug in infinity. By plugging infinity, I'm going to get 10 minus some infinite thing over 5 plus some infinite thing, which is some negative infinity over infinity. So if I try to plug in this kind of infinite term, I'd get infinity over infinity. This means I can use L'Hopital's rule. What does L'Hopital's rule say? It says I can take the derivative of the top and the derivative of the bottom and then retry my limit. So the derivative of the top, the 10 is going to go away, and this can become negative 12x. And the 5 is going to go away, and we get 3 dx. And this is still trying to plug in infinity. If I do it again, I still get infinity over infinity, so I do it again. And on the top, I'm just going to get negative 12. On the bottom, I'm going to get some infinite thing. And we know when we take a number and divide it by a really, really big number, like infinity, like a billion or something, we're going to get a really small number out. So my limit's going to end up being b, which is 0. All right, let R be the region bounded by these two graphs. All right, what is the area of R? And so first thing we might have to draw a picture. All right, the line is slightly easier. 2x is just this line. All right, 4x minus x squared is going to be some parabola, because the negative x squared is going to be going downward. All right, so it's going to look something like this. And it doesn't have to be exact, I just have to get a basic idea of what's happening. All right, so we want to try to find this region. And we know the area of a curve. Because we're talking about area, there's going to be some integral involved. All right, integral is kind of shorthand for area. It's going to be the area from the left side to the right side of the top function minus the bottom function. All right, so first of all, we have to figure out what are these two values. Those two values are where these things hit each other, so we need to figure out when is 2x equal to 4x minus x squared. Well, if I add over, I get x squared minus 2x equals 0. X times x minus 2 equals 0. By factoring out x equals 0 and 2. And so now we know those are the bounds. And the top function based on my picture looks like 4x minus x squared. I'm going to subtract the bottom picture, or the bottom of the area, which is the red one. And this place is nice because it actually doesn't matter. If I were to flip these two, my final answer would be negative, but you can see there's no negative answers here. So if I would just pick the positive of that value, so if you accidentally mix these up, it's not really the end of the world. But I can do a little bit of simplifying. 4x minus 2x is going to be 2x. Then we do the reverse power rule. And we plug in the top function first. Subtract when we plug in the bottom function, which is just going to be a 0 because everything goes away. 4 minus 8 over 3. We need to get a common denominator. 4 is going to be 12 over 3 minus 8 over 3, which is 4 over 3, and that's an answer, so that's a pretty good sign. All right, that's B. All right, so this one, they give us a graph of f, and they say g is defined in this weird way. What is g prime of 2? All right, we want to find g prime of 2. The first thing we'll do is find g prime of x. And if we're taking the derivative of something that looks like this, we have to do the quotient rule. So the quotient rule is low, which is f of x, times d high, so the derivative of the top is 2x, minus high, so the original top, d low, which is going to be the derivative of f, which we can just say is f prime, over the original bottom squared. right, so that's the derivative function. Again, it's weird because there's an actual function notation in there. But now we want to plug in 2. F of 2 times 2 times 2 minus 2 squared plus 1 times f prime of 2 all over f of 2 squared. All right, so we just need to figure out what all these things are. Well, first of all, f of 2 is when I plug in 2 into my original function, which is going to be 2 is here, plug it in, I get 3. So f of 2 equals 3. F prime of 2 is the derivative of 2, which is the slope of the tangent line. When you're on a line already, the tangent line is the line itself. All right, so now for the derivative, I just need to find the slope of this line. All right, so we're doing rise over run. Like that's an exact point, and that's an exact point. So I'm going up 4 over 1, rise over 1, and I get 4. So now I'm just going to plug everything in and simplify. All right, so this was, we'll probably write it up here. So this is right up here. F of 2 is 3. 2 times 2 is 4. 2 squared plus 1 is 5. F prime of 2 is 4. On the bottom, f of 2 is 3 squared is 9. 12 minus 20 over 9. Negative 8 over 9. And it's always good when what you get is an answer. All right, looks like the answer is A. All right, so for this problem, we're trying to find the integral from -1 to 1 of some function. So this is the second part of the fundamental theorem of calculus. The first thing you do is find the antiderivative of that function and then plug in 1 and -1. All right, so the first thing you do, how do we do the antiderivative? All right, again, the fraction bar makes it a little bit more difficult, so we need to figure out a way to get rid of the fraction bar. Really, our two ways are doing some type of substitution. All right, but there's really nothing inside of another function here, so there's no real good pick for what u would be. All right, so the other way we had to do this is rewriting this fraction as two separate fractions. And one hint to do that is when you just kind of have a single term on the bottom, you can split up into separate pieces. X squared over x is x minus 1. So x squared minus x over x is the same as x minus 1. And now I can take the antiderivative of that. And I'm going to get 1/2 x squared minus x. And now I want to take that and evaluate it at -1 and 1. All right, remember that means we're going to plug in the top value first. So down here, I'm going to plug in 1 first. Then subtract when I plug in -1. And for these ones, you just have to be really careful with your negatives. And so 1 squared is 1. -1 squared is also 1. And then distribute that negative. So 2 1/2s cancel, and those two -1s make -2. So the answer should be A. All right, the table above gives selected values for the differentiable function f. All right, must there be a number c such that f prime of c equals 2? All right, so this is a kind of a hidden example of the mean value theorem. All right, the mean value theorem says if I have some continuous and differentiable function, I first can figure out the slope of the secant line, all right, that connects the kind of two endpoints. And the mean value theorem says there's going to be some value c somewhere along the way where the tangent line is parallel, and this one is actually two different places, or that tangent line is parallel to the secant line. Other words, the slope is the same. All right, so if we're trying to find an interval where there has to be a tangent line of slope 2, we're basically asked what secant line has slope 2. So we're going to go through all these different intervals and see what the secant line slopes are. So first, the 0, 4, all right, the x value is 0, 8 over 4 minus 0. That's -2, so that's not going to be it. All right, at 4, 8, 2 minus 0, or 8 minus 4. That's just the difference in the y values of the outputs over the difference in the inputs. That's 1/2, so that's not going to work. 8 to 12, you get 10 minus 2 over 12 minus 8. That one's 2, so that should be the answer, but let's just double check. The last one's 16 1 minus 10 over 16 minus 12. Oh, that's definitely not it. So the only one where the secant line has slope 2 corresponds with the interval where we know there has to be a tangent line with slope 2. So the answer is C.